This is a video series on C for embedded systems. Arrays in C. This is a part 2. In the part 1, we have seen what is an array, how to define an array, and how to initialize the elements, and how do we access those elements, and also we have seen what happens if you uh, access the out of bound array element. So in this video, let's focus on finding the size of an array, and also we'll touch upon multidimensional arrays. Finding the size of an array. So we have already seen that in C, we have a size of operator to compute the number of bytes that a variable of a given type occupies. So the size of operator works with the arrays as arrays too. So we can find out the size of the array with the size of operator. Suppose that you declare an array with the following elements. Say you have double the value 5 of 5, then you have 1.5, 2.5, 3.5, 4.5, and 5.5. These are the initialized values, and you can output the number of bytes that the array occupies with the following element, with the following statement. So here is basically what we have done is we just output the uh, value of the number of bytes that array consumes with the size of values. So let's see with an example this a little bit later, and you can obtain the number of bytes occupied by a single element of the array with the expression size of value 0. So size of value 0 basically means it will give you the first element of the array, and then we take the size of that. So the memory occupied by an array is the size of a single element multiplied by total number of elements. Thus, you can use size of operator to calculate the number of elements in an array. So similar to element count, which is equal to size of values. This is the complete size of array it gives, and then size of the first element. So because you can apply size of operator to data type, you could have written the previous statement to calculate the number of array elements as follows. So instead of using the values 0, you can actually do something like size of values and size of double, because the size of the first element or each element is of double, which is 8 bytes in a 32-bit architecture. So you can use size of operator when you use loop to process all the elements in an array. So let's see whatever we saw before with this example. So I'll just just build this first, GCC, and then array size.c. And then let's execute it at exe. It produces size of array is 40 bytes, and there are 5 elements of 8 bytes each. The sum of the values is okay, whatever. So now let's see what we are doing here. So inside a main, we have declared or defined uh, an array of values of to contain 5 elements. So these are 1.5, 2.5, 3.5, 4.5, and 5.5. So this is the entire array what we have defined. And then the element count is basically a size of the total array size of values, divided by size of values 0, which is the first element. Now we're printing size of the array is with the size of values, this one. So I did not give the uh, new line character here, so probably, I mean, that's important, and there are so many count elements of size of each byte. So I'll recompile this. So you can see that the size of array is 40 bytes. The line number 7 prints 40 bytes, and there are 5 elements of 8 bytes each, because the size of double is 8. So, so the next is the initialization. Okay, this is done, and how do we access it? Here we are just calculating the sum of the values. So in the for loop, we just add sum equal to 0 0.0, and then iteratively we add the each element to sum. So well, this is about this program. Let's go ahead. Okay, now we will see a little bit about multidimensional arrays. So first, let's start with two-dimensional array and work our way up. A two-dimensional array can be declared as follows. So here, this is the data type, and this is the name of the array, and then you will have two values given within two uh, braces, square brackets. The, the, this declares a carrots array with three sets of five floating point elements. So note that each dimension is between its two pair of square braces. This is one dimension and this is another dimension. So now here in this we have two-dimensional array, because there are two dimensions here. So you can visualize a two-dimensional array as a rectangular arrangement like rows of vegetables in a field. So it's like rows and columns. So you can visualize the carrots array as having three rows and five columns. They're actually stored in memory sequentially by row, as shown in figure below. So what happens is the compiler basically uh, the in the target, the arrays are stored in a linear fashion like this, but we can visualize like rows and columns. So in rows and columns is how we visualize. So we can see that the right mode index varies most rapidly. The left index conceptually selects a row. The right index selects an element within a row. So here the numbers 0, 0, 1, 2, 3, 4, and this is the number 1, number 2. So this is, you can assume this as the 3 is rows and 5 is a column. So the amount of memory allocated to each element is, of course, depends on the type of variable that the array contains. So in this case, uh, in the book it is a floating, so which will consume 4 bytes. So well, next we will see a three-dimensional array, which is a straightforward extension of two-dimensional arrays. So here you can see that we have declared a double, we have declared array of beans, which is of type double, and it contains three dimensions, 4, 10, and 20. So the first dimension is contains 4 value, and next is 10, and next is 20. So you can think this as an array with 800 elements. So you can visualize it as a storing yields from beans plants, where there are 3 fields, each containing 10 rows, and which each row contains 20 plants. So you can see that the idea can be extended to define arrays with as many dimensions as required. So you can see that to visualize, let's say, a three-dimensional array is simple, wherein you can visualize it as a yields from beans where there are three fields. So let's say you can think like as three fields, different fields, and then each field contains 10 rows, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like this 10 rows, and each row contains 20 plants. So each row basically contains 20 plants. That's how you can visualize. I hope this is clear. Next is how to initialize a multi-dimensional array. So initializing a two-dimensional array is similar to what we have done so far in one-dimensional arrays. The difference is that you put initial values for each row between braces and then enclose all the rows between braces. So like this. So int, so we have a numbers array of numbers of type int. It's a two-dimensional array. So each set of values that initialize the elements in a row is between the braces, and the whole lot goes between another pair of braces. The values for a row are separated by commas, and each set of row values is separated from the next set by comma. So the way to visualize this initialization is basically you have three rows and you can have three sets of values between the braces, and we have four columns. That means each row contains four values and they are between the braces, and each row is separated by a comma. So that is how we do an initialization. So if you specify a few initialization values, then there are elements in a row. The values will be assigned to row elements in sequence, starting with the first. The remaining elements in a row that are left when the initial values have been assigned will be initialized to 0. You can initialize the whole array with 0 just by supplying one value. So like this, where numbers 3, 4 of type int, and you just initialize every element with the value 0. Similarly, how we initialize the one-dimensional array. So for arrays of 3 dimension or more dimensions, the process is extended. A 3-dimensional array, for example, will have 3 levels of nested braces with the inner level containing sets of initializing values for a row. So you can see that this is a 3-dimensional array where it contains 2 blocks of 3 rows which have 4 columns. So like this is how you can visualize. So you can initialize a 3-dimensional array. So you can see the initializing values are between an outer pair of braces that enclose 2 blocks of 3 rows, each row between braces. So each row is also between braces, so you have 3 levels of nested braces for a 3-dimensional array. So you can see that 1 nested, 2 nested, and 3 nested. So that is the level of uh, brackets you will find. So this is generally true. So for instance, a 6-dimensional array will have 6 levels of nested braces enclosing the initial values for the elements. So you can omit the braces around the list for each row and the initialization will still work. But including the braces for the row values is much safer because you're much likely to make a mistake. Of course, if you want to supply a few initial values, then there are elements in a row, you must include braces around the row values. So what this paragraph saying is that each dimension, for example, one dimension will have one closing braces, 2 dimension will have 2 levels of closing braces, and then 3-dimensional will have one more layer of closing braces, and so on and so forth. So how do we process the multidimensional arrays? So you need a nested loop to process all the elements in a multidimensional array. The levels of nesting will be the number of array dimensions. So let's see that in this example. So in this example, okay, first let's see GCC. Let's compile this if it compiles. Okay, so what we've done is we have declared, so we have defined and initialized three-dimensional array of integers, and we are just trying to calculate the sum of some of the numbers in that array. So as we see that initialization is happening, so here the first dimension is 2, so we have two bigger blocks, and then you have a second dimension is 3, that's why we have 3 rows of initialization for each block, and the third dimension is 4, which is the number of columns or number of elements that this row has. So that is how initialization is. And then what is important to note is that for processing the multi-dimension, in this case 3 dimension, you have 3 nested loops. And for example, you have I, J, and K. So the outer loop will loop through the block here, I mean the first dimension, and the next J basically will loop through the rows here within each block, and K will actually loop through the number of elements for within the array. So that is how you have to think. And uh, what happens is that now the way to access each element is that the three-dimensional array is that we have to pass the values each time as we iterate over the for loop. We have these values uh, calculated accordingly. So for example, when everything is 0, it becomes numbers 0, 0, 0, so something like this. Numbers 0, 0, 0 is the first element, and then in the second iteration, it becomes number 0, 0, and 1, and so forth. That is how the values are accessed, and each value is added to the sum. And finally, we have a sum of all the numbers, which is 828. So I hope this is clear. So each loop iterates over one array dimension. For each value of ji, the loop controlled by j will execute completely, and for each value of j, the loop controlled by k will execute completely. So as I explained, so there are a lot more arrays, lot more to arrays. We will learn more about uh, arrays and solving practical problems in our future projects. Well, that's all for this video. Thanks for watching.
Subscribe to the channel for more projects, courses, tutorials, and tools.